Hello. In this video, we shall discuss about the CNN. Okay. Now, for the images, I have taken the flowers as the images. Now, let me show you types of flowers. Total, there are total five types of flowers. Mm, in each and every folder, we do have its own images. Now, let's start our coding. Let's import the required things. Now, let's add sequential. Now let's add feature extraction layers, conventional 2D related. Let me add the first layer. Now in this first layer, we are going to have 32 filters and 3 comma 3 filter size, and the input shape of the image is like 180 by 180 by 3, and activation function is the relu. Now let's add one more layer that is related to the max pooling. Now max pooling is going to compress the image by retaining the important features. Okay, in the same way, let's add few more layers. Like I have added one layer which consists of 64 filters, one more layer which consists of 128 filters. Now, currently this whole thing is in 2D matrix. Now the next thing which we are going to work is on fully connected layers. For that, we need to convert this 2D matrix to the 1D vector. For that, we need to flatten this. Okay, now let's start our fully connected layers. Let me add the first layer. Now in this first layer, we are going to have 256 features, so 256 neurons, which is going to read the features which we got from the above. Okay. Now let's add a dropout layer. Randomly, this will drop some zero point 0.5 neurons. Okay. Now this we use to maximize the performance. Now let's add one more layer which consists of 128 neurons. What this 128 neurons will do is, like, whatever the features which it receives from this first layer, it is going to focus more important features, okay, than of focusing on all. It focuses on more important features. Okay. Now let's add one more dropout layer. Now let's add our final. As we are going to have five classes, so that's why we have added five over here, and coming to the activation function is the softmax. Now let's compile it. Let me add the height and batch size. Now in the next step, we are going to do data augmentation. Let me We are going to do the data augmentation of the image, like rescaling it, changing the weight, flipping it. Okay, all these kind of data augmentation we are going to do just to make our performance very well. Let's add our train data set. Okay, in this train data set, we are going to add the folder. That means we are going to have multiple folders, like that we are going to add over here, and as well along with the batch size, target size, like image height, image width, all these things we are going to add. Now in the same way, let's add even for the validation data set. The same thing, even this is going to consist of. Now let's see what are the class names are present. Earlier I have shown you the folders, right? So the names have to appear. Okay. Now our main code has been completed. Now the last step which we have to do is uh, training. Training will take really very longer. So currently I'm going to pause the video. Okay. Let me start the training and I'll pause the video. Okay. Hello. Now the training has been completed. Now the accuracy which we have received some around 85. Though now let's do the prediction. Let's import the required things which we require for the prediction. Let me take one sample image. Let me load the image. Do I have added image height with this for the information? I'm adding height and width as well. Let me resize the image. As the image which we are sending, even that has to be in 180 by 180 pixel. Now let's expand that dimensions. Now let's do the prediction. Now send that the classrooms. Now let's see what's the flower name which we have received. The flower name is Tracy. Now let's add another image. Some flower image on the bottom of some flower image. Okay. To increase the accuracy, it would be good if we increase more epochs. Okay. This is the whole flow of the CNN. Thank you for watching this video.